It's very exciting for us here today because we've been looking for a use for the big dish. Oh, this is my phone. We've been looking for a big dish, and it's very exciting for us to get involved with CIT. And they're very, very proactive, very, very involved. And since we started talking to them, it's been a very quick and responsive relationship so far. For us, getting the big dish back up and running and maintaining the dish and getting this asset back online is very important. And I think for the country it's a great thing as well. So today, we have some words from the Minister, and I'll just leave the Minister in a second, and then we'll go through details and questions and answers with Niall. And if you have questions for me afterwards, we're all here, so that would be fantastic. So first, I'd like to welcome the Minister, Sean Sherlock, Minister for State for Science and Innovation, to say a few words. Thanks very much.
Thank you very much. I just want to, first of all, to thank you for the invitation to be here today. As a Minister for Research and Innovation, with no scientific or research background, I must admit that I'm on a very steep learning curve, and representing this constituency, I must admit that I possess a certain degree of a lack of knowledge as to what this station was for. So I'm glad, I'm delighted to be here today, because the tour, the whirlwind tour that I was just given there by Rory was really gave me a good briefing and an understanding as to what its future potential is. And I think that's the key, is the future potential of sites like this and the involvement of the state agencies, the European Space Agency, Enterprise Ireland, and the synergies that are founded between the institutions like CIT and UCC and others. So what we have here on our own doorstep has the potential to become a very key infrastructural centre in terms of research and in terms of commercialisation vis-a-vis satellite use and so on. But I must refer to the briefing that I received in relation to some of the work that's going on, and particularly in relation to radio telescopes. And somebody might fill in my gaps on the knowledge on this one. What will the radio telescope detect? The radio telescope will detect a host of cosmic phenomena, from the quiet emission of giant clouds, of slowly moving hydrogen clouds, to the violent cataclysmic explosions of stars as they explode, from the interruptions of the solar surface to the pulsing of neutron stars, from the storms of Jupiter to the enormous galaxy-scale jets of quasars. Now, to a layman like myself, that's it's a language that I hope over time that you'll be able to penetrate, but I think it's important that the state is funding this kind of research, because there are new boundaries being pushed out all the time, and I think if Ireland is on the curve or ahead of the curve in terms of that kind of research, then I think it adds weight to how we sell ourselves as a nation, because we show to the world that we are right on the curve of any kind of research that's happening, no matter where that research is, and I think that will only benefit us in the long term. That's my honest opinion on that. So while for laymen like myself, who are mere mortals, mere politicians, I think it's important that we have faith that the research is taking place, even though we may not always be able to come to grips with the kind of language. But I have to say that when one looks at the future potential of sites like this, it's not only the basic research or the applied research, but it's also the commercialisation and the number of jobs that it supports presently, which could be roughly 20 jobs, but there's a future potential of maybe 3 times that, possibly more. But it's important though that we are investing in projects like this, because I think it signals to the world that we have the potential to be able to deliver research and deliver projects of this nature, and it puts us, as I say, right in the forefront of technological and other research. So I'm delighted to be associated with this. I hope to deepen my understanding through conversations with Niall and others, and I have to say that I'm always very well briefed as well by Enterprise Ireland and by department officials, who I find have a very in-depth knowledge of the potential of projects of this, like this, and I think we have to keep funding them because I think it's important. There will be competing, we will be competing for resources, and sometimes it's very difficult to try and make cases to the Department of Finance, let's be honest about it, when it comes to funding research applied and basic. But I think it's important that we do ensure that we try and maintain that level of research because it will support jobs, it does support industry, and I think we have to try and keep it on the agenda. If we don't support the research, if we don't fund the research, it will actually compromise our ability, one, to attract the FDI, but two, to retain the companies that we already have in this country, and they're big name companies. If we do not support that kind of research on an ongoing basis, we will slip down the line, and I think it's vital that we send a message that we can continue to fund projects of this nature. And it's a bit of, dare I use the term, a bit of blue sky thinking, but that's the space where we need to be in right now. Because if we're not in that space, we're going to fall behind the curve, I think, in the long term. So I'm delighted to be here today. I want to thank you for the invitation, and it's as I say, a steep learning curve, but it's wonderful, and this is all on our doorstep. So I'm greatly enthused by this opportunity. Thank you very much.
Right, now before we go into Niall's presentation, there's one or two people I'd just like to thank. We've had fantastic support. You mentioned Enterprise Ireland. We have some of the lads from Enterprise Ireland here today. They have been amazing, not just on these specific areas for research and for space, but right through the different sectors, because we actually overlap many different departments and areas. The strange thing with space is that you cover from transport to marine to defence. Every department has a communications, satellite, space fit. So we've had guys from Enterprise Ireland from right across the spread help us, which has been fantastic, and thank you for that. We've also had very, very strong support from government so far. But the big thing here, and I was teasing Niall earlier on, it's for the kids. You don't want to say, but one of the major things that's exciting about this is that we get to get a huge asset like this back working where it will be accessible to students. And with that in mind now, I'd like to hand you over to Niall to go through the detail of what we're planning.
Thank you very much, Rory. In case anybody's worried about the detail, it will be a short, brief detail, so not to worry about that. First of all, Minister Shella, thank you very much for coming here this morning. And I, first of all, on behalf of CIT, would like to thank the National Space Centre, Rory and his colleagues, for giving us the opportunity to work together. Very often we see that, so if you like, it's on the exchequer funded side of things, tries to encourage industry to get involved, whereas in this case it's actually industry saying, well look, we have this asset, can we use this to do something useful? And the short answer is very much yes. And the first question that I would ask is the usual, the age-old one, does size matter? And in this case, it absolutely does. This is a 32-metre dish, and it's one of the largest radio dishes in Europe. You've all seen it this morning. The first thing I hope that came to your mind was, wow, it's just huge. So from that perspective alone, from doing the kids, it's fantastic. If you think about it, it's about 1,500 times more sensitive than a dish that you would have at home, sort of the satellite dish that you would get for your Sky TV. And because it's so much larger and more sensitive, it means that we can look at things, and I'll give one or two examples, that are very faint in space. And this gives you a competitive advantage. Bigger in this case really is better. You can actually see things that other people can't see. That usually makes collaborators, because we're at the start of a process here. This is not the end of anything, this is the start. Usually collaborators like it if you give them a competitive advantage. They will work with you. This gives Ireland a competitive advantage in a number of areas in research, but otherwhere as well. And some of you will have seen the 9-metre dishes. This is on the side. This is roughly 12 times more sensitive than those. So the issue is, how does this work? And the minister said, you know, steep learning curve. So here's hopefully bring you as far up the steep learning curve as you really need to go. If you think about it, there's a dish at the moment sitting out there, and it's pointing upwards. So in space, as we speak, there are objects which are emitting radio waves. And I said this to one or two colleagues earlier. Those radio waves hit the dish all the time. They bounce, they come here, they bounce off the dish, they bounce into this retroreflector here and down into the centre part here, where for the last number of years nothing has happened. So all this radio information from objects which are possibly near the early start of the universe, the radiation from them has passed by galaxies, it's passed by stars, it's passed by, who knows, maybe inhabited planets. Who knows what the actual path of those radio waves have been. And they decide, in their infinite wisdom, to come all the way down to Elfordstown. They hit this 32-metre dish, and then nothing useful happens after that. What a waste. That's such a pity. So what we want to do is we want to actually allow those radio waves, which are naturally captured by this large dish with its sensitivity, and put a series of detectors just here at the focus. So it's very much like an ordinary camera or an ordinary optical telescope, and the key thing here is that you capture more radio waves because the dish is large. Now, the other key thing is this is a 24/7 operation. It's miserable, it's not miserable out today, but it's windy, it's refreshing out today, as we found out outside. But the radio dish is detecting radios quite happily right now. Again, they're not going anywhere right of a particular note at the moment, but during the day, during night, weekends, whatever, it can be used. Now this is hugely advantageous for a number of reasons. In this country, if you wanted to show kids the sky, or show anybody the sky, let's say show kids or the parents the sky, you have to choose your moments optically. Radio, you don't. It's on tap all the time. So this allows us to schedule interactions with schools, and we can say you will get observations from the 32-metre at this time, and it's guaranteed. So that's very, very useful from a pragmatic logistics point of view. If we think about what we're going to do, the first phase, which is the one that we're announcing today, is to install new detectors in here where the old detectors would have been. And these detectors will, I'll show you one or two brief examples, but they'll give us the first sight on the universe which the Elfordstown 32-metre has seen in quite some time. Now previously it wasn't actually, the type of detectors we'll put in aren't the same as would have been used for communications with satellites. So but all the time, even when it was looking at satellites years ago, it was detecting this radiation and we were just doing nothing with it. It's amazing in that sense. So, we're in an economic recession, we have a big telescope, surely the country has better things to do. Well, actually, this would cost you 10 million if you were to buy it, conservative estimate. And what we're going to do to bring it back to life is spend no more than 10k. In fact, it's about 3.5k is what we'll put in. But if we actually, yeah, I know. So what we really need, Minister, is lots of money. The whole point here, in reality, is this is a value for money project. The phase one, to bring it back to life, is enormous value for money. This is thinking outside the box. It's not waiting, it's not looking for huge exchequer or other funding. The 10k is going from CIT because we can bring this back to life and we can do some really useful things with it. We're always talking about value for money and the need for value for money. This is, to me, well, you do the ratio, a factor of 1,000 to 1. I don't know how many projects are running in the country which are giving 10 million euros worth of kit and saying that we'll actually bring it back to life for 10,000 euro. So I think that's something that's very nice. Phase one. At the moment, this dish is stationary. So what we can do, of course, is rely on the fact that the earth rotates and the sky goes over you, and you can make maps of the sky like this. And this just shows hydrogen. So there's clumps of hydrogen here, clumps of hydrogen here, particular clumps of hydrogen here. This black bit is where there's no data. This is not from this dish, by the way, because we don't have the detectors on this dish at the minute. But we'll also then be able to, if we find something of interest, we can zoom in on that and get a little bit more detail. This isn't completely trivial, but this is something that we have to work towards as part of the phase one. But what's nice about it is because the earth rotates, it means that we don't actually have to spend or worry about the complete refurbishment of the dish. Actually, how do I F3?
F3.
There we go. I just did it. This is what the dish may look like when it's moving. And the reason I'm just showing this 30 seconds of other dish antenna moving is, and these are mostly speeded up, is however impressive it is standing looking upwards, it's amazing when it starts to move around. And when you actually get to see, for example, through webcams or people visiting the site, imagine a kid saying, I want to point this at over there, and they see the radio telescope move in real time. 32 meters, however many hundreds or thousands of tons of metal moving and pointing, and then taking that data for them. I mean, that's got to get you excited. And that's why this type of massive engineering, if you like, is so impressive from the point of view of the kids. What would we be able to see once we're able to move the dish? Well, you can see these galaxies, and some galaxies, this is an entire galaxy in here, which is 100,000 million stars, and for some reason, which we still don't understand, it's throwing out material in two directions. We can start to look at those. We can start to analyse that data here from Elfordstown, or in a much more genteel set of observations, we can look at these giant clouds of gas. Why are they important? Well, we all come from them. That's why they're important. You and me all ultimately come from clouds of gas which were floating around, which got pulled into stars and planets, and basically made you and me. So understanding these and even knowing that tells us something about who we are as a species, our place in the universe. But rather than just looking at pictures of them, we can build up some pictures. And that's very exciting. But you can also do something which you might say is more practical. We all know about solar storms, and the only thing I want to show you with this graph is you can see things changing here, the yellow line going up and down, and the blue going up and down. The sun is active all the time. So by being able to look at solar activity, we can do things like, for example, predict when we need to do something with spacecraft, so to protect them, turn them away from the sun, whatever it may be. Now, Elfordstown wasn't really the only place doing this. There are other research groups in the country who want to do this and are doing this type of thing, but there's lots and lots of possibilities. The one that we're probably most interested in initially is the schools. And so here's Elfordstown, and here's Blackrock Castle Observatory. So this is owned by the City Council and run by CIT. So the city, we all own basically the actual infrastructure, and CIT runs the facility there. So the first thing that we will do is link directly Elfordstown to Blackrock, so when you come there, you can actually see what Elfordstown is viewing. And that's really very exciting, because you have now an internationally award-winning interactive visitor centre, with about 120,000 visitors since we opened, able to see what's going on in Elfordstown in an environment which is designed to present information to people as they come, visitors, schools, whatever it may be. But we can do something even more than that. What we intend to do, very simply, because in CIT and a couple of the departments who are represented here are particularly good at this type of activity, we're going to place a number of sensors on the dish. And sensors are important because it's one of the key things that the government has recognised we need our kids to understand more about, because it leads you into the whole thing about taking data and understanding about real world applications. But you can put a sensor in a room like this, or you can put a sensor on a 32-metre radio telescope. Now for me, and I admit I'm biased, this is kind of cool, because now in your classroom you can see, for example, whether the telescope is moving, because you can look at the accelerometer data, you can see how hot it is, you can see which side of it's in the sun and which in the shade, you can look at the temperature, humidity, and all the rest. And imagine if you then go to move the telescope and you watch the sensor data move as you move the telescope. So this brings the whole lot together into something that's very, very real. But you can do better, because we have sensors at Blackrock. So you link those in, and the same interface, as you're moving this, you can compare what's going on. Is the temperature at Elfordstown the same here? All sorts of possibilities of linking sites together. But of course, it doesn't have to be just at Blackrock, because once you're on the internet, you can connect into schools across the country. So now you have the possibility, which is what we're working towards, of allowing schools to use data from sensors at various sites, one of which will be this, and also schools to control the telescope. So while we're starting off in Cork, and while you have to put the telescope somewhere, the reality is this is an all-Ireland project. And what we want to do is, we want people to come up with ideas and tell us, how about we try this? So this is an open invitation for people to look innovatively at the use of this type of facility. So the other thing is, some of you may have seen, if you visited the site, we have an exhibit called Send a Message to Space. And what we actually do is we take a 1.5 metre dish, it points at a star which has a known planet around it, you write a message and we send it towards that star. This actually is our most popular exhibit. We had it at the Science Exhibition, that tremendous return there. But imagine you sent a signal to a 32 metre instead of a 1.5 metre. I mean, that's pretty cool. So that's another thing that we can already do, technically, once we have the dish movable. Incidentally, I don't think moving the dish is going to be an issue. The dish has been parked in its current position. Everything works fine on it. We just haven't been moving it yet. We don't see that, and I think we've talked this over quite a bit, but that's going to be an issue. But we didn't want to wait. We wanted to get the thing up and running and so on, which is why we're going to do it even before it moves. But imagine sending a message to space from one of the largest telescopes in Europe. Why is that important? Well, let's suppose you send a message to a planet. The teachers can then say, okay, let's imagine what might the conditions be on that planet. And then they can start to think about things like what's an atmosphere, what are greenhouse gases. You can actually talk about climate change on other planets. But it's the context in which you do it. Rather than just say, I learned about climate change, you say, today I sent a message towards another planet, far away, millions of light years away, or tens of light years away ideally, because it won't take so long to get there. And we talked all about the greenhouse gas emission. I mean, to me, that's the context of the discussion is now so much more interesting. It's the same basic discussion, because of course, physics, chemistry, well, we don't know about biology, but physics, chemistry, and so on appear to be the same everywhere in the universe. So there are then other things, I'm almost finished, in the engineering and science arena. Possibilities for students at second level and third level. There's mechanical issues, electrical and electronic. Electrical, so the heavy duty motors, electronics to do with all sorts of sensors. There's clearly telecoms issues, there's clearly computer science. And importantly, and I put it in a different colour, it's all about multidisciplinary. So we need to bring, and we can bring teams of students from the physics department, from mechanical engineering, from computer science, from electronics and electrical and electronic engineering, and put them together to work on student projects. They can come from CIT, they can come from UCC, they can come from UCD, they can come from wherever they want to come from. So the whole point is that we use this as a facility where multidisciplinary teams learn in a real life environment how to work with a piece of kit that hopefully will excite them. But there is another angle to the whole thing. This is an iconic facility. And I don't know if any of you remember, there used to be an ad on the radio only an hour from Dublin, and it was for Navan carpets. Okay, well this is only 5 minutes from Midleton and the world famous Jameson Distillery. So you can now use this as well as a hook for the area, for East Cork, to say, come to East Cork. Okay, we don't have this, we can't have lots of people running on site at the minute, but this is thinking forward. How might we go with this? And you know, now what we're doing is something that we try to do at Blackrock, at the castle there. Bring culture, tourism, art, and connect it with science directly, so that it becomes part of the culture. And the minister talked about, you know, the need to research how important it is, and that's absolutely true. My position in CIT as head of research, you know, one of the reasons why I'm involved in that position in CIT is I also believe very much that that's very important for us from a society point of view, not just an economy point of view. There are many possibilities, and the reason I actually just didn't say many, because we don't want to be saying these are the only ones. So it's whatever possibilities people can think of. There's lots of opportunities for the future. So there's lots of things in the research side of things. In the phase 2, once we're able to move the telescope, we can start to look at some of the things that the minister mentioned already, and I showed 1 or 2 sort of pictures of those. So there's lots of different things that you can do. But a point I also made is that the size of it makes it attractive for collaborators. So it may well be that we have people who want to put better instrumentation than that we're going to put on, link it up internationally with other radio telescopes and so forth. Great. If that's where we can go in the future, then that's fantastic. So the minister also mentions, my second last slide, enterprise. Well, we're not really in the business of saying to the National Science Centre what sort of enterprise might make most use of it. But from my perspective, when we were talking about this, we thought, well, look, whenever there's a faint signal, that's when it's useful, because it's a big dish. So if you need something which needs a lot of sensitivity, this is your man. If you need less sensitivity, you can use a different dish. So in a sense, this gives you possibilities. And there is actually a 34-meter telescope in the US, which actually is controlled by students. Okay, it's the something Apple Valley Radio Telescope. Goldstone, thank you, Al. Apple Valley Radio Telescope, and it's used to support NASA missions. So you could imagine sort of ESA missions, for example, Mars missions, return data that are faint signals. They could actually now be coming through Midleton. Now that'd be exciting as well. But you can also augment the receiver with a transceiver. So you could, for example, at one point the 32 meter was connecting across the Atlantic for telephone calls. You could do other things with it as well. I mean, there's lots of possibilities for enterprise. I mean, very sort of standoffish in the comments because who knows what enterprise might want to do with it. But the key point is that Big Dish is basically good. And as the final thing, we don't have a name for the telescope. So what we're going to do is we're going to have a national school competition to name the 32 metre. We haven't decided on what the prize might be yet. But we think that would be a very interesting way as well of getting schools involved with it. And also, it would be really nice to be able to call it something. I don't know if any of you are familiar, and this will be my final comment. In Burren County, Offaly, the largest telescope in the world for almost 80 years resided there. We've got a world class. Ireland in the 19th century was world class. And they call that the Leviathan of Parsonstown. Parsonstown was the townland, and because it was so big they called it the Leviathan of Parsonstown. So maybe we'll have the Somethington of Elfordstown, or who knows, and that will also start to work its way into the Irish culture and Irish psyche. So as a final comment, can I thank all my colleagues in CIT as well as my colleagues at Blackrock Castle and everybody from the Space Centre, and also from the funding agencies as well, or the support agencies, because actually the next thing that we really need to do with this isn't so much as to get lots and lots of dosh in the first instance. Sorry, Rory, if we actually said that, but is to actually move this along and really sort of to bring people along and build this into the project, because we have an iconic piece of infrastructure on our doorstep, and it's now going to be lit up. And actually, just in case you're wondering when it will be lit up, we intend installing the new set of equipment into this at the end of June. So we'll have another announcement about when the actual switch on will occur, sometime over the summer, once we've done all the engineering tests and so on. So thank you very much, and thanks again to the National Space Centre for giving us this opportunity to do this project.
Okay, just very briefly before we finish up, the contacts for this are our Chief Technical Officer Bruce Hanna, who is partially the reason why we're doing this, because Bruce is very interested in space and always has been, and from day one has pushed us to get something done with this. So he's our point of contact, and for the radio telescope side and the astronomy side, it's Niall. So if you have any questions that you want to ask now, you can ask them, or if you want to grab them and push them into a corner and grill them for information anywhere here now, it's fine too. So any questions? Okay, well look, thank you very much for coming. Thank you, Minister, for coming down. It's obviously a very exciting thing for us. There's coffee and tea there, you're welcome to. And if anyone wants a quick walk around the site now, we're welcome to give you a tour. Yeah? Okay.